Welcome back to the Explainer. Today we're tearing into something absolutely incredible for developers and data scientists. We're looking at AITrailblazer. We're going to explore exactly how this system takes what is usually entirely static, dormant publication archives, those really dense research papers, and actively transforms them into functional, living agent memory.
So think about it. What actually happens when you turn a static research archive into living, persistent AI memory? It's a massive question, right? And right up front, I really want to clarify something for us. We aren't just looking at theory today. No way. We are analyzing a functional, running application that operates right in the browser. It's built specifically to fundamentally change how we interact with vast amounts of published research.
Okay, let's dive into this. Part 1, Beyond the Chat Box. We are moving right into our first major paradigm shift, stepping away from the standard AI interaction model we've all become so deeply accustomed to.
We all know the unconstrained chat box, right? It's often messy, it's incredibly forgetful from prompt to prompt, and it simply doesn't hold on to deep, structured context. AITrailblazer completely counters this with a controlled workflow. In the demo we're analyzing today, the user actually manually opens a HUT publishing proof directly in the browser. You don't just type some vague prompt and hope for the best anymore. You trigger a highly controlled sequence that literally forces the AI to operate within strict, defined boundaries.
Moving on to Part 2, the Agent Memory Workflow. This is all about building reusable packets. Honestly, this is where the magic really happens under the hood, where a Cloud Run agent receives a request and calls the publishing workflow to return a completely reusable packet.
Let's move to and see how this builds. This core loop systematically converts a raw archive into highly reliable memory. First, we start with the archive context. That's the published research itself. Then, step 2, we assign it a stable trip code identity. From there, we establish river memory for a continuous flow of context. We lock all of that down with a MongoDB-backed state, and finally, we run a Gemini-ready synthesis. The whole shebang systematically converts raw, unstructured data into highly structured agent memory.
All right, Part 3, Trip Code and Addressable Memory. Now we're getting into the technical jargon that makes this entire system tick, signaling a major paradigm shift in how AI actually recalls information.
So a trip code, like the specific HUT River 001 you see in the demo, is a stable resolver handle. Think of it as a permanent mailing address for an AI's memory. It acts as a rock-solid handle, connecting the article memory, the river context, the MongoDB fit, and all monitor next actions. Instead of the AI trying to reread everything you've ever provided every single time, it simply looks up this stable address. It's a real game changer.
Published content becomes addressable agent memory. Now, this brilliantly illustrates the absolute key product idea of the entire AITrailblazer demo. You aren't just uploading a static document for an AI to read once and immediately forget. You are literally giving that published content a permanent home in the AI's operating brain, so it can be called upon exactly when it's needed.
And this leads us to an incredible double reveal of the archive brief in the first runtime step. First, the system generates a raw JSON proof package. It spits out these machine-readable fields specifically to prove that it's an actual routed response-driving automated follow-up workflows. It's not just some visual mock-up. Then, it takes that exact same bounded response and renders it into a beautifully polished HTML packet for human readers. It's one bounded response, serving both machine and human perfectly. Moving to Part 4, Persistent Context Across Sessions. Let's shift our focus to what actually happens when the browser runs a second-turn follow-up query.
Now, what's really interesting about this slide is that the user doesn't have to restate the full archive context or manually paste the trip code chain all over again. Because the agent preserves context from the previous river automatically, subsequent turns are effortless. The memory is stateful and persistent. The agent just knows.
Part 5, a cost-aware cloud reality. Let's bring this explainer home by focusing on the real-world deployment viability, the usage visibility, and the tech stack.
So, the crucial point is that this entire system isn't just some local prototype. It operates as a functional Google Cloud browser and API workflow. It features protected demo access, a deeply integrated MongoDB-oriented memory model, and highly repeatable actions. But crucially, check out the cost-aware usage ledger. The demo actively tracks every single operation, giving you complete visibility into what this stateful memory actually costs to run in a live cloud environment.
I want to conclude our explainer today with a final provocative thought to leave a lasting impact. If your archives could remember, what would they build next? Seriously, think about the untapped potential of your own static data waiting to be unlocked. Thank you so much for joining me today, and as always, keep learning.